Okay, so today I'm going to talk about GPS and map reading. So I've got three GPSs here. The first is a Garmin GPS 73. So this is one of the sort of newer models that we've got at the university. And this is the one I'm going to be mostly focusing on today. I've also got one of our older style GPS 72. You can see that it's a little bit battered. It's been quite well used by a lot of students in a lot of units over the years. And indeed, in some of the models, the buttons have started to fall off. So we try to no longer use these ones unless we're desperate. There's nothing wrong with these older GPS units. It's just that they're worn and they're starting to break down. The third type of GPS that I've got here is my mobile phone. So what I've done is on my mobile phone, I've uploaded an app. It's called Australia Topo Maps. It's free to download on your mobile phone, and it's using the same satellite system as what a commercial GPS is using. So it's a good alternative if you don't own your own GPS unit. So here's our three GPS units. I'm going to be mostly focusing today on our Garmin GPS 73. The first thing I'm going to do is turn the GPS unit on, and I do this by pressing the red button. And when the screen turns on, it shows a home page with a menu of different options. But before using the GPS, it's a good idea to check the setup and the various settings. This is in case the person who used it before you set it up differently, because you don't want to actually go and take your readings and then come back to find that it was in the wrong projection or the wrong datum. And this does sometimes happen. So it's always good practice to, when you're using a unit that is not your own, so this is a shared instrument, that you check the settings before you use it. So to do that, I use the arrows to scroll down and scroll across, and I go to Setup on my menu and press Select. I then press Select for System, and the first thing I'm going to just check is that it's set to GPS. So my satellite system is set on GPS. GPS stands for Global Positioning System. It's a network of 31 satellites with 24 at any one time operating in the sky. They're all owned by the US government, but they're freely accessible and provide you with location information when you have an unobstructed view of 3 or more satellites. So this is the satellite system that your sat-nav or your mobile phone, when it's set to GPS, is also using. So if you click on GPS, there's also another option that says GPS plus GLONASS. And GLONASS is the Russian satellite system. So you should turn this on if you have poor visibility of the sky, such as if you're in a narrow valley or a gorge, or you're under a dense tree canopy, as this will provide you with a more accurate position information. But for most of the time, using just on GPS is perfectly adequate for our purposes. So I'm going to go back to my menu. So the next thing that we want to check is the datum and projection settings. So from Setup, I want to scroll down to Position Format, which is just down here. Press Select, and the screen shows 3 variables: Position Format, Map Datum, and Map Spheroid. So on my GPS, I've selected UTM UPS, which stands for Universal Transverse Mercator, Universal Polar Stereographic. It's a big word, you don't really need to remember that. Just remember UTM UPS, or UTM. UTM is the standard international coordinate projection system that can be used with many different types of map datums, and that's the one that we want to use. So for my map datum, I've selected GDA 94, which stands for Geocentric Datum of Australia 1994. It's the standard system that we use to define location, so the horizontal datum, whereas AHD, which stands for Australian Height Datum, is the standard system that we use to define elevation, so the vertical datum. So we're using GDA 94 because my unit here is a few years old, and that's the only option available to us. Whereas GDA 94 has just been superseded by GDA 2020 this year, But because my unit's a few years old, it doesn't have that option available to me. So we're still going to use GDA 94. And indeed, many of our topographic maps also are in GDA 94 rather than the new map datum GDA 2020. It'll take a little while for maps to catch up with that new datum. You could also use WGS 84 for your map datum, and that stands for World Geodetic System 1984. WGS 84 is directly comparable to GDA 94. So I'm just going to go back out and then scroll up to units, because the third thing that we want to check is that our measurement units are in the correct sequence or the correct numbers. So I'm looking to set my, I've set my GPS up so that it's in metric. I've got elevation in meters, depth in meters. It's particularly elevation. Okay, so now I've set up my GPS. I'm just going to go back to my page. I'm now going to navigate through some of the pages of my GPS. And the first thing I'm going to check is the number of satellites that I have and the accuracy of my GPS position. So because the GPS works by triangulating location based on the position of satellites in the sky, I need at least 3 satellites. But the more satellites my GPS can get a fix on, the more accurate will be my location. So from the home page, I want to scroll down to more functions and press enter. I then want to scroll down through my menu until I get to satellite and press enter again. And here is my image of the satellites that my GPS has a fix on and the numbers of those satellites. So that each satellite has its own unique number. So I've got it, I'm actually standing in my lounge room, but even still I've got a pretty good fix of my satellites. I've got 1, 2, 3, 4, 5, 6, 7, 8 satellites that my GPS has picked up. My accuracy is 4 meters. And here are my coordinates just to the left, the top left-hand corner. It says they're in UTMs, and we'll explore a little bit later when we're looking at a map what these mean. But here is my coordinates and here is my fix on satellites. So I've got quite a good fix. If you were in a gorge or under a dense tree canopy, your GPS might struggle to, say, get 2 or 3 satellites, and that's when you want to enable those other functions, like the GLONASS function, to try to help your GPS get a fix on more satellites. So I'm just going to go back out of my menu, back to my home page. So the next thing I want to view is the GPS coordinates and elevation. So this is a faster way to get to your coordinates from the home page. So I'm going to scroll down till I get to mark waypoint and press select. So here are my coordinates here. I've got my elevation in meters, 1,090 meters. There's a date and also a little number at the top. So if I've got a field notebook, I can write down these GPS coordinates in my field notebook. Alternatively, what I can do is I can actually save these GPS coordinates as a waypoint in my instrument that I can actually download later on. So like at the end of the day, once I've finished my fieldwork. So if I want to do that, I can either leave it as a number. So this is number 167. Or I can change it and give it a name. So I might call it, site 53, and then just press done, and it'll save that GPS coordinate into my unit, and I can move on to the next GPS reading. So that's a good way of doing that. It's great if you've got your own GPS where you can easily download it yourself later. When you're often using shared instruments, it's better sometimes just to write down the numbers in your book. It only takes you a couple of seconds. You can just write it down in your field book and you've already got the information there. So I'm just going to go back out to my main menu. Okay, so I'm now going to talk about map coordinate systems. And there are 2 types of coordinate systems shown on maps. The first is the geographic coordinate system. And this is a coordinate system that is used to define the locations on the Earth. So because the Earth is a sphere, I'm using my globe here as my prop. The geographic coordinate systems uses latitude and longitude and is expressed in degrees, minutes, seconds, or decimal degrees. So the 0 degree latitude is the equator, which is shown here. So the North Pole is positive 90 degrees or 90 degrees north, and anything south is negative 90 degrees or 90 degrees south. Sydney is around about 34 degrees south in latitude, longitude. For longitude, the 0 line goes through the Greenwich Meridian, which is located in London. So here's my 0 line, goes through part of Africa. And anything that is east of the Greenwich Meridian, so this way, is positive to 180 degrees. Anything that is west of the 0 line, so this direction, is negative 180 degrees. And so the lines actually join around at the international date line in the Pacific. Here's Australia and Sydney. So just right down here. So here we are at sort of 34 degrees south and about 150 degrees east. Okay, the second map system is the projected coordinate system. This is the system that we use when we take the Earth's surface and lay it flat on the table, like in a map. Here's an example topographic map that I'm going to use. It's the Katoomba 1 to 25,000 map, and I'm going to be using it to plot my GPS coordinates. So projected coordinate systems use zones, eastings and northings, which are expressed in meters. So my map is 1 to 25,000 scale. This means that each centimetre is equivalent to 25,000 centimetres or 250 metres. So every 1 centimetre on my map is equal to 250 metres. On the x-axis of my map are the eastings, which are shown here. So this easting is labelled 246000. I've got 247000, 248, 49, 50, and so on. So my eastings increase as I'm moving east. The distance between each easting is 1,000 metres. So on my map here, this is 4 centimetres. Each centimetre is equivalent to 250 metres. So the total distance is 1,000 metres between each easting. On my y-axis, I've got my northings. My northings here start at 6263,000. I've got 6264,000. 65, 66, and so on. So my northings also increase as I'm going north, and the distance is also 1,000 metres between each northing. Also on my map, I've got a grid system that is shown. It's following each of the eastings and northings. So the grid is also 1,000 metres by 1,000 metres. And the grid system basically helps us plot our location when we're sort of on the centre of the map and away from those map margins. So it's kind of a tool that helps us with plotting our coordinates. If we just go back to our GPS for a second, here's our reading from the other day. And what you'll notice under location is it says 56H02451H7. 6279529. So you'll remember that we set our GPS up for UTM as our position format. UTM divides the globe into 60 vertical zones, which are numbered 1 to 60, and 20 horizontal bands, which are labelled C to X. Sydney is in zone 56H, and that's what's shown here on our GPS location. So the 56H is our UTM zone. The numbers that are next to it are our eastings. So the 0245187, that's our easting. So here I've got 246, so my 245 is just off the map here. And our second row of numbers is our northing, so 6279. So I've got 6263, so 79 is also quite a bit further north on this map. So our GPS is showing us our UTM zone, our eastings and our northings, and we can relate that to the eastings and northings on our topographic map. So on the weekend, I took a GPS reading of the start location for my bushwalk, and we're now going to find that location on the Katoomba topographic map. So here's my GPS reading here. So I've got my zone 56H, and then my easting 0250995 and my northing 6273241. So I'm going to find these eastings and northings on my topographic map here. So still on my Katoomba 1 to 25,000. So I first start with the easting. So that's the 0250995. And the first thing I'm going to locate is that 0250 line. So here's 250, here's 251. So here's my easting just here. And I know that my GPS coordinate is somewhere between this easting and this easting. So I'll just put a little label just there like that. So for my northing, I know that it says 6273. So over here, I've got my northing 7374. So I know that my coordinate is somewhere between these two lines. So if I just go across, it's somewhere in around here. So I'll just move that up like that. So my location was somewhere in this grid square. I can use the last three digits of both my eastings and northing to help me work out where I am in the grid square. Because I know that each 4 centimetre grid is equivalent to 1,000 metres, and my eastings and northings are also in metres, I can work this out using a simple mathematical equation. So it works like this. I just take 4 centimetres divided by 1,000 metres and times it by the last 3 digits of my GPS. So for my easting, it would be 4 divided by 1,000 times by 995, and that gives me 3.98 centimetres. So 250, so I've got to go 3.98 centimetres across. So I'm almost at the 5-1 easting line here. So I'm only a couple of millimetres off. For my northing, it would be 4 divided by 1,000 times by 241, and that gives me 0.96 centimetres. So almost a centimetre along. So I'm just going to put this little post-it note here to show you. So I'm almost a centimetre up from my 7.3 northing. So that means that my starting location, my coordinate, is approximately in this position here. I was actually at the start of the Grand Canyon walk. So I can do this a similar sort of process for all of my other GPS recordings. What I first do is use the first 4 digits to work out which grid square I am in for my eastings and my northings, and then calculate how far across each grid square I am to work out that more precise location within that grid square. When I was out there doing my bushwalk, I also compared my GPS location to the GPS location on my mobile phone using the Australia Topo Maps app, and the app location was within 10 metres of my GPS, so it's a pretty good substitute if you don't have a GPS. So you can go and do a similar thing using your mobile phone. So you can also use your Topo Map to obtain GPS coordinates. And this can be useful if you're planning to go out to a field site and need to locate particular features. So you can enter the coordinates into your GPS and use them to locate the site on the ground. So for example, I'm going to just remove these for a second. I want to go out to a field site out here, which is just near Junction Rock, on the confluence of Govetts Leap Brook and Govetts Creek. So here's my location just marked here with a cross. My easting is midway between 5.2 and 5.3. So if I'm writing this down in my notebook, I'd be writing 252, and then I need to work out what the last 3 digits are. And to do that, I'm going to use my ruler. So if I take my ruler, I measure across, and it's almost exactly 2 centimeters. So 2 centimeters, so at a scale of 1 centimeter is 250 meters, that means I'm 500 meters across. So my easting would be 252500. For my northing, I need to go across to my map to look at what that is. And that says 6275. So that's my northing line. I also need to do a similar thing with my ruler and measure up. And it's about 1.3 centimeters. So using a little bit of maths, it equals to be 325 meters. So my northing would be 6275325. So I can now take those coordinates that I've obtained from my map and put them into my GPS, and I can use that to help me navigate when I'm actually out there in the field to find my field location. So normally in class we would do an exercise on recording the GPS coordinates for several locations on campus and plot these on a topographic map. You can do a similar activity yourself in your own local area by using the Australia Topo Maps GPS app on your mobile phone. Identify a few key sites in your area, such as a park or a train station or a shopping centre, and visit these to record the GPS coordinates in eastings and northings. Then go to the 6 Maps eTopo, download a free PDF of the topographic map that covers your area, and plot these GPS coordinates on the map. You also need to complete the assessment on GPS and map reading, and the details for that are in the Week 6 folder.